Good evening. I'm Dr. Thurman, and this is a special report from Bayside Action News. Today, we investigate what scientists are calling the Bayside air crisis using our data from our environmental team. We found elevated levels of primary pollutants like nitrogen oxides, sulfur dioxide, and particulate matter, largely from vehicle traffic, shipping activity near Echo Bay, and industrial emissions. But the problem doesn't stop there. These primary pollutants react in the atmosphere to form secondary pollutants, including ground level ozone and secondary particulate matter, making the air even more dangerous over time. What is happening in Bayside's atmosphere, and why are these neighborhoods suffering more than others? We'll find out.
Power plants release air pollutants such as sulfur dioxide, nitrogen oxides, and particulate matter, which can lower air quality in nearby communities. These pollutants may increase the risk of respiratory problems like asthma and bronchitis, especially among children and the elderly. Long-term exposure can also contribute to heart disease and other chronic health conditions. As a result, as we see in Bayside, communities located close to power plants often experience high healthcare costs and reduced overall quality of life.
I'm Dr. Wilkenmeyer. Thanks, Dr. Thurman. Our data shows that sunlight drives chemical reactions between NOx and volatile organic compounds, forming ground-level ozone, a key component of thermochemical smog. This is why ozone levels spike in the afternoon. At the same time, temperature inversions trap pollutants near the surface, preventing vertical mixing. Bayside's coastal geography makes this worse. Sea breezes push polluted air inland during the day, then trap it against surrounding hills. We also observed atmospheric deposition, meaning pollutants eventually settle into Echo Bay through dry particles and rainfall. Over time, this transfers air pollution into aquatic systems. This explains why some impacts appear daily, like afternoon smog spikes, while others, such as ecosystem damage, develop over years. This graph on my left shows how nitrogen oxides and ozone change throughout the day in Bayside. Notice that NOx spikes during the morning and evening rush hours when vehicle emissions are highest. In contrast, ozone peaks in the middle of the day because sunlight drives chemical reactions between NOx and oxygen, forming O3. This pattern shows how traffic and sunlight combine to worsen daytime air pollution and increase health risks.
Thank you, Dr. Wilkenmeyer. I'm Dr. McAnderson. Our spatial analysis shows clear disparities. Neighborhoods closer to highways and industrial zones, especially the South Bayside district, experience consistently higher PM 2.5 concentrations compared to coastal residential areas. This disproportionate exposure means communities near emission sources face greater health risks. Ecologically, nitrogen deposition into Echo Bay contributes to nutrient loading, which can trigger algae blooms. These blooms reduce dissolved oxygen, harming fish and aquatic biodiversity. On land, ozone damages plant tissues, reducing photosynthesis and weakening vegetation over time. Air pollution in Bayside is not just an atmospheric issue, it's reshaping ecosystems both in and out of the water.
Our graphs here show the relationship between particulate matter and the hour and change in temperature. On calm days, meaning days with less wind, particulate matter is higher. Meanwhile, on windy days, particulate matter is lower. A higher change in temperature also relates to calmer days and more particulate matter.
In the graph, we can see the Echo Bay Maricultural Farms histogram. And then here we can see that as time continues through the year 2000 to 2025, the shell thickness index decreases because of the lack of calcium in the soil. And then as a result, that then impacts the mortality rate because with a thicker shell comes a higher mortality rate and lower survival rate for the marine creatures.
Thank you, Dr. McAnderson. I am Agent Lucas, the scientist. The health data tells a concerning story. Higher PM 2.5 exposure is linked to increased asthma rates, especially among children in South Bayside. Fine particles penetrate deep into the lungs, causing inflammation and worsening respiratory conditions. Ground level ozone further irritates airways, increasing ER visits on high smog days, but solutions are possible. Evidence-based mitigation strategies include the following: stricter emission standards for shipping and industrial facilities, expanding public transportation to reduce vehicle and NOx emissions, electrification of buses and port equipment, urban tree planting to improve air filtration, and community air monitoring programs to ensure environmental justice. By targeting both primary emissions and secondary pollutant formation, Bayside can reduce health disparities and protect both people and ecosystems.
The data is clear. Emissions, weather patterns, and geography are working together to amplify pollution in Bayside, and the impacts are not equally shared. This has been a Bayside Action News investigative report. I'm Dr. Thurman. Thank you for watching. On to you, Jamie.
Goodbye.